Hello, listeners and viewers. So in today's topic, as we are still progressing with the topic that we started earlier in the previous video, the topic was on linear motion, and now we are on example 4. And just before we continue, please subscribe to my channel in case you have not subscribed, so that in case of any new video, you are among the first people to view it or to be notified on the same. So let us look at this example 4. We are told that a train driver moving at 40 kilometers per hour applies brakes so that there is a constant retardation of 0.5 meters per square seconds. Find the time taken before the train stops. So this question again is a question that requires a little bit of critical thinking, even though it is very straightforward. So let us look at how to solve this problem. So solution. So we are told that a train driver was initially moving at 40 kilometers per hour. So this 40 kilometers per hour, it was initially moving. So to mean 40 kilometers per hour is going to be our initial velocity. So initial velocity, and initial velocity in the previous videos I told you that it is normally abbreviated as small u, and then we also have got the final velocity. Final velocity here, we are told that a train driver was moving at 40 kilometers per hour, applies brakes so that there is a constant retardation of 0.5 meters per square seconds. Find the time taken before the train comes to stop. So when the train is coming to stop, it means that the final velocity of this this train is going to be 0. When the train stops, it means that its speed or its velocity is at 0. So our initial velocity was at 40 kilometers per hour, and our final velocity, we expect it to be at 0 kilometers per hour. So when we have this, and there is this term here, retardation. Retardation normally means deceleration. So retardation is a synonym of deceleration. So the moment you see this word as retardation, it means that this one is a deceleration. And when you see this term deceleration, then the value given here, we expect this value to be given as a positive number. Otherwise, when we want to mean the same thing in deceleration here, with the same value, then the moment we use acceleration instead of deceleration, and yet this thing was reducing in speed, then you will be given here a number which is negative. But the moment you see a positive number here, and the term that has been used here is either retardation or deceleration, then it is fine. But if the term here was acceleration, and here the value has been given in negative, then just know that they are still meaning deceleration. So in this case, we are told that it was retardating, to mean it was decelerating at 0.5 meters per second. So we are being told to find the time taken before the train stops. And from the previous video, we learned how to find acceleration. And acceleration A was equals to V, which was the final velocity, minus U, which was the initial velocity, over the T1 minus T0. And T1 was the final time, minus T0 was the initial time. So in the question here, we were given retardation. Retardation was meaning deceleration. But in our equation, in our formula here, we are having an acceleration instead of deceleration. Then what does this imply? This therefore implies that deceleration is normally deceleration d deceleration is normally equals to, sorry, yes, this deceleration is normally equals to the negative of acceleration. In other words, when you are decelerating, it means you are reducing in speed. So therefore, in this value here, this value we were given as a deceleration. So we need to get it in terms of its acceleration. In terms of its acceleration, we will therefore have to negate this value. So therefore, our A here will be equals to negative 0.5. It won't be 0.5 as such because this one was deceleration. But in our formula, we are having acceleration. So we need to deal with this 0.5 here in acceleration format, where we are now going to negate it. The moment we negate it, then it means that it was decelerating. So 0.5, and our u was 40 kilometers per hour. So again, we need to convert this 40 kilometers per hour into meters per second. And we know that, so this 40 kilometers per hour, this means that, so 40 kilometers per hour converted to meters per second. So you say that if 40 kilometers is being traveled in 1 hour, so we need to convert this one into meters per second. So the easiest way to do so is by taking 40, which is this one, multiply by 1,000 over 3,600, and this one goes there, that one goes there. So 4 goes here 1, 4 goes here 9, so 4 goes there 10. So that is 100 over 9. So uh, so 100 divided by 9 is 11.11. So this one is equals to 11.11 meters per second. So this one is our initial velocity. So let us now then substitute all these values here and get our total time taken, because the question is asking on the total time taken. So our final velocity, so our A there is going to be negative 0.5 is going to be equals to our V. Our V will be the final velocity. And since this thing was coming to rest, it means that its speed will be at 0 minus our initial velocity, which was 11.11 meters per second. Then you divide by t. So we need to eliminate this t here. This t here is not looking good. So when we want to get to be left with the, need to make t the subject, So this one, first of all, is the same as negative 0.5 to be equals to 0 minus this one. 0 minus 11.11 is going to be negative 11.11 over t. So when we want to make t the subject, then t will be equals to negative of 11.11 divided by negative 0.5. And this negative and negative will cancel. So we'll therefore have 11.11 divided by 0.5. So answer divided by 0.5. Then you get 22.22 seconds. So our change in t, therefore is going to be equals to 22.22 seconds. And that will be our answer. And guys, please, if you have not subscribed, please hit the subscription button and subscribe. Thank you for listening.